So, today we are going to discuss about we have finished our discussion of this DLL. So, now we will start discussing about other two layer of networking, which is the network layer and transport layer. That should be the end of our this particular course. So, we will try to see today it will be we will be mostly concentrating on the IP layer, the associated protocol, how it helps in transferring packet end to end. So, that is something and its philosophy of course. And then we will start taking decision about how these two layers DLL, we have talked about that interlayer communication. So, how DLL layer and IP layer work together towards some unified goal. So, that is also something we will try to see, and we will try to see how these two things together along with physical layer of course actually does the whole networking. So, that is also something we will try to depict. Okay. So, if we just try to see the topics that will be covered in this particular week. So, one will be the of course IP header, then IP addressing, that is very important, then this ARP DHCP, that is about address resolution kind of thing, and then some routing protocol. So, that should end our discussion about this network layer. And then we will go to the transport layer. Mostly we will discuss about TCP, which has been the predominant transport layer protocol probably. And then we will discuss something about NAT, which is again interplay between transport layer and IP layer. So, we will talk about that also. And then finally, we will end our course with the TCP flow control, which is one of the most important part of TCP actually, the transport layer part. Not only flow control, there will be also congestion control and how TCP provides reliability on top of IP datagram network, which is not reliable, which is hop by hop. We will start talking about these philosophies later on. So, if we talk about this IP, we have already talked about this. This is actually called the Internet Protocol or IP. This is the layer 3, which is the networking layer, which is responsible for delivering data from one particular address to another address, or one particular destination source to another destination. So, that is this layer's duty. We have already talked about that every layer has its own duty, like the data link layer, that is actually the access part. It's means we have already talked about that its duty is somehow if the access is common, then among multiple contender, how do we resolve those contention, and how do you actually give meaningful transmission in the access part of the network. Now, this internet protocol actually joins everything, the entire network end to end, and then it actually means think about delivering whatever you want to generate in any source of the network, and then to the other part where the destination lies. So, we will try to see any protocol that is described. We have seen that it is all about the header. You add the header, and associated with that there will be some task. So, over this particular protocol we will try to understand how the header helps to do specific task and what are the specification over there, and each node reading the header, how they can decide things and what are the other things they do on top of that header. Okay. So, that is something we will try to see. So, their task with along with header, and how this header specification, header reading and header writing and this performing the associated task, how that actually generates the whole networking task as a whole. Okay. So, before going into this protocol, let us try to see what exactly is required from this protocol. So, that is something first we will try to describe. So, suppose what has happened, you have a network where this is the source node. Okay. So, there is an access part of the network. So, let us say this is connected to some access part of the network, then that will be again going and connecting to some metro part of the network. So, let us say this is metro, and then it might have the backbone. So, the backbone network, then you can have another metro followed by access, and then the destination node. Okay. So, now this source node wish to communicate to this particular destination node, right. So, what will be happening? In the access part, of course, there will be some let us call that access gateway. Okay. So, this might be our if it is wireless access, this might be the access point. If this is Ethernet, so whatever if there is a final switch that is connected to Ethernet, that might be that switch. Okay. So, and followed by, of course, it will be connected to metro with a router. We will talk about this router. So far we have talked about the switches, but we still have not talked about this router. Routers are those devices which actually operates up to layer 3. So, it goes beyond DLL layer, it can read the header of the IP layer or the network layer. Okay. So, there will be an associated router which we can call as the means metro edge router or something like that. Okay. So, it's actually the gateway to the metro, and after that there will be multiple routers in the metro who will be interconnected through some form of networking, and then there will be in the backbone there will be again a means metro core router which connects it to the backbone. Again backbone might have its own networking, which are all routers of different dimension. So, they will be connected with some form of networking, and it goes on like that. So, basically whenever we are talking about this sending data from this sender to this destination, what we will have to do is something like this. Generally all the sender destination, they will have a unique ID which is called the IP address. This has to be globally unique. So, that is something which we will be putting in the header, source ID and destination ID, we will talk about that. So, IP address is something which has to be unique, like our earlier telephony number. So, this is something which has to be unique, and every source and destination will be given this unique number. Okay. So, globally unique, even though I am calling that, you will see later on when we will be discussing about NAT, it might not be always unique. So, that is something it might be locally unique, but might not be globally unique, but that is a different story. Okay. But generally our understanding is this source and destination, they have unique IP addresses, and this with this IP addresses we know they are means where are they located, okay, in the network. Okay. So, that is something will be with this address only, it is like postal address. So, basically you give that address, then that letter will be delivered like this. Here also this packet, if you give that address, it will be delivered. So, in the place of address you have to and from. So, this source ID is that from part of our mailing, and this destination ID is this to. So, who is sending and to whom it is being sent, that is being encoded inside the packet header. So, header specifies this, that has nothing to do with the datagram. Whatever you will be having actual data, you append this so that you know who is sending and to whom it has to be sent. Okay. So, whichever destination you choose that IP address. So, that is all you will have to do. Once you do that, this internet protocol is a hop by hop, or it is called a connectionless protocol. Or it is also called hop by hop protocol. What does that means? Now, this particular data has to be transferred to this destination, but directly it will not be done that way. What will be happening? He will first give it to this router. This router then decides which next router it has to go, that is why it is called hop by hop. So, basically source does not know about the destination, he just puts this destination ID and he forgets about that. He tells the network to do this entire forwarding. Okay. So, basically what he does, he just delivers this packet to the next hop, and he washes his hand from this particular packet, he does not care about this packet right now. So, inherently this does not have any reliability, you actually do not know whether the packet will be delivered, you are just hoping the network will somehow deliver this packet. So, your duty is just to give it to the next router. The next router's also duty is not to deliver the whole packet to the destination. He will also do the same thing, he will just deliver it to the next router, and so on, it will just keep on going. So, like this it will keep on happening and then finally it will reach to the destination. That is why it is called connection-less protocol, because you do not establish any connection between source and destination. That also helps us in terms of, if you remember in the beginning of this course we started discussing about this circuit switch network and packet switch network. This is actually packet switch network. So, therefore, we do not really create a connection, end to end connectivity we do not really create. What we create, we only think about the next hop, and the next router we think that he will be intelligent enough to route it to the next destination, which will be closer to the destination. So, that is in some manner, okay. Conceptually it is closer to the destination. So, distance wise it might be closer to the destination, or delay wise it is closer to the destination. That means, if I forward this packet to this router instead of this router, I will probably reduce the delay, overall delay of the packet delivery. So, they intelligently does just these things. Every router is concerned about his own hop, not the end destination, and somehow in a distributed fashion they do very nice job. So, that every packets which are being routed, in the same time what might happen, there might be another station which is another source, he might be looking for another destination connected somewhere. It might be also connected over here, there might be another metro access followed by another destination. So, it might happen that he wants to now source 2, this was source 1, destination 1, source 2 wants to send it to destination 2, this might also happen. So, if that has to happen, these two packets simultaneously will be routed. So, as you can see, this router will handle both the packets, okay. One packet will come from here, another packet will go from here. So, both this packet he will handle, and then accordingly he will decide, because both the packets has unique IDs. The source ID and destination ID are not same, they have different IDs. Seeing those IDs, somehow routers will be routing them to the next hop in an intelligent manner. So, that if you take all these routers decision, finally the packet will be correctly delivered to the destination. So, that is why it is called connection-less protocol. It is, of course, it is part of packet switching. So, it does facilitate our statistical multiplexing very nicely, because nowhere you are establishing connection, you are not putting a complete link, you are not reserving anything. So, you are just delivering to the next hop, next router again puts them in buffer, and then whenever there are availability they will forward it to the next router, and every router takes this intelligent decision of where it has to forward, so that it goes towards the destination. Okay. That is the whole idea of IP routing. Okay. So, that is why it is called connection-less protocol. It has no reliability whatsoever. I do not know if a source is transmitting a packet, I really do not know whether the packet has been delivered or not. Okay. If some router is faulty, it might be clubbed over there, it might be lost over there. So, you will see later on, because this particular layer, IP layer, does not have any reliability. So, we had to put another layer above that, which is the TCP layer, or which is the transport layer, which will start putting reliability on top of it, and that is why that will be more of a connection oriented networking. You will see that later on when we will be discussing about TCP. So, TCP governs this reliability on top of a non-reliable IP network layer protocol, okay, which is a hop by hop. I really do not know whether my packet is finally delivered to the destination. Network keeps absolutely no monitoring about this. That is the job of the layer above, okay, which provides this reliability. Well, when we discuss TCP along with IP and TCP, we will actually discuss why this philosophy has been proposed. Why not some other philosophy? Why not providing reliability from the network layer itself? Why this has been divided, subdivided? Why this entire task of reliably transferring packet from one source to another destination and other source to their respective destination? Why this has been divided, subdivided into two tasks? One is just delivering the packet, and the other one was adding reliability on top of that. So, that is something we will try to appreciate right now. We know that these two layers does this together, but this has been separated out and IP layer has deliberately taken this connectionless protocol. There are benefit of that, we will talk about that later on. But we have at least understood what will be the philosophy of this IP packet forwarding. So, this kind of packet forwarding is called store and forward. So, every router what it does, it actually store the packet in its buffer. So, whenever it arrives, it stores the packet in its buffer, then it reads the header. From the header, the most important part it reads is which destination ID it is looking for. So, where I have to send. Accordingly, we will later on know that there will be a routing table which will be there in the router, every router will have that. From that routing table, he will understand what will be the next router he should forward this towards that destination. So, that he can actually forward this, expedite the process of forwarding this packet towards that destination. So, that he will take decision from his routing table. How he updates his routing table, that is a separate issue, that is the routing protocol, we will talk about that later also. So, he takes that decision and then forwards the packet to the next hop, that is all he does, he does not do anything else. So, that is why it is called stored and forward, and of course, in between he takes that routing decision. So, he store the packet, reads the header, does the routing, then there whenever the link is available he forwards that packet with the help of statistical multiplexing. So, that is exactly every router does that. So, every router will be keep on doing that hop by hop, and after multiple number of hops it will be finally reaching to the destination. Okay. So, let us try to see how, means whenever we define a protocol, we have already talked about that there should be an header. So, how the header of IP which will be appended along with the IP data, means whatever data will be given by the transport layer, it will append this header on top of that data. So, application layer will give some amount of data, then transport layer will add the TCP header, and then the IP layer will add its IP header, okay. And then it will deliver this to the corresponding DLL layer of the same node. Okay. So, that is what will be happening. So, IP layer will just add this header. What are the fields of this header and what they do? We will not go into the details of everything, but some of the things we will start describing over here. So, if you see, this is a typical header that I have already drawn. Okay. So, I have drawn this header of course in a square matrix kind of thing, but it will not be like that. It will be, this is actually 32 bit. So, this part is 32 bit. Okay. So, I have subdivided, it is actually one 32 bit, next 32 bit, next and next, 5 such, this one makes the header. There is a option field which we might keep, we might not keep, we will not discuss about that, okay, due to time crunch. So, that is not that important also. Okay. So, I have shown it this way, but actually it will be a bit stream. So, it will start from here like the television screen, the way we scan that. So, it will go up to this 32 bit and then it will again start from this side and it will go from this direction. So, always it goes from this direction to this direction, one row it picks, then the next row, then the next row, like this it will be a series of bit stream. For the ease of demonstration, we have depicted it in a square box kind of pattern. Okay. So, you understand what exactly is happening. So, the first field which is actually, so this is 32 bit, this is actually a 16 bit mark. So, that is the 16. So, basically if you take from 1 to 16, 16 to 32, okay. This is 8 bit mark, this is 4 bit mark. Okay. So, if you see the first 4 bit specifies the version. Currently mostly IP version 4 is being used. So, we are generally using version 4, but it has been actually upgraded already to version 6. IPv6 is already being used, but not everywhere, still IPv4 is predominant. So, we will talk about mostly the version 4, but version 6 is almost similar, just enhancing some of the fields, and it is a little longer header. Okay. So, this version actually specifies which version we are taking. For 4 there is a unique identifier, 4 bit identifier, and for 6 there will be another identifier, any future version that comes that will have a different identifier. So, why this version has to be specified? It is again a very important philosophy of networking, that whenever you upgrade your network from version 4 to version 6 let us say, you always assume that some of the versions or some of the network tools or network component of that version are already there, they have been used, they are serving their purpose. So, suddenly overnight you will not be completely taking them away from the network, and you will not be completely installing a new networking, this is not expected. So, generally networking development goes scale by scale or gradually it happens. So, basically whatever is there overnight you do not throw the entire thing, entire infrastructure, that will be too costly. So, basically on that infrastructure slowly one by one you actually modify this. What does that means? That means the interoperability, backward compatibility, these kind of terms are very important, or coexistence, they are very important. So, whenever you have a network, it must have both the things, they must coexist. If they coexist, some of the things, suppose IP version 4 is there, all routers are of version 4. Now, you want to install a version 8 router, few version 8 router in some portion of the network, you install them, but those routers will have capability of reading both version 6 and version 4. So, they will have capability of both. Therefore, some of the IP version 4 packets which are coming from other section of the network, they will be capable of reading that. But how do they discriminate these two packets? That is where this particular fields come as handy. So, whatever will be specified over there, if it says version 4 or if it gives the unique ID of version 4, then it will be version 4. If it is unique ID of version 6, then it will be version 6. So, remember whenever you are doing a networking designing, you will have to keep this in mind, always keep things backward compatible, keep provision for coexistence, and whatever new you are installing, that must be, as I have said, backward compatible. That means it should have capability of the new one as well as the older one, because networking is all about everybody should be able to talk to everybody else. Now, you install a new network among few users. Now, if that is standalone, then it will be an isolated island where those users only can talk to each other, because the entire network protocol is upgraded version and it cannot understand the earlier version. Then you have a big problem, because you are creating an island and it cannot communicate to anybody else. That is not the purpose of networking. Networking has the purpose of providing communication between any user, any two users, they should be able to freely talk. So, therefore, whenever you do this networking upgradation, that is for your own purpose, but user won't understand that, they only need connectivity. So, you have to provide this backward compatibility. So, that is why, as you can see from the header, people have started thinking about that backward compatibility. So, that is why that version field has been specified. So, any packet which is coming with version 4, so that will have version 4 identifier at the beginning. So, any header, IP header which is being read, first they will read that version, according to that version reading, whatever unique ID they will get. If it is version 4, they will read the entire header according to version 4's protocol, okay, or specification. If it is written as version 6, they will read the entire header according to version 6 specification. So, this is how they will discriminate between version 4 and version 6. Okay. So, the next field, again another 4-bit field which is called IP header length. So, this is happening because I have put this options. Okay. If the option field are varying, then the IP header is no longer a fixed header. Even if it is version 4, it might not be fixed. Okay. So, that is why I have to specify the header length. So, that 4 byte will be able to specify how many option fields I am padding over there and what is the overall length of the IP header. So, that whenever I read this IP header, next by reading this IP header length, he will be able to calculate how far header is there and where from the actual data starts. This is very important, otherwise I will not be able to know where the header ends and where the data field actually starts. So, therefore, that has to be specified. After that, there is a type of service, this is for priority. IP has specified different kind of priority classes. There is diff serve integrated service. So, different kind of priorities that has been provided, so that different class of traffic like voice, video and all kinds of other classes can be handled. For the time being, we will skip this part, that is we will not be taking our focus into that particular part. That is a big discussion again, how IP provides this priority or class of service, how it handles those things. Next is total length, it is 16 bit. Okay. So, with this 16 bit we specify what will be the total length. Already we have specified the header length over here, but this is header plus data, what is the length, because when IP packets are coming we will be seeing a bit stream. We do not know exactly where the header starts and where the packet will be ending. So, this from starting point to find out the ending point, we need to really know what is the overall length of the packet. So, this particular byte specifies for this particular packet, whichever packet I am appending this header, what is the length of that. So, this means because I have a total length field, so that means IP datagram can be of variable size, it does not have to be fixed. I can specify whatever length I want to put and accordingly the length will be put. Okay. The next 32 bit field, the next row, this is all about fragmentation. So, this is something we need to discuss, that IP data sometimes what might happen, it might go through some of the network where it cannot handle very long packet. Okay. So, if you have a wireless link, if you give a very long packet, then what might happen, most of the packet will be erroneous, because the bit error rate is not that low, it might be of the order of 10 to the power minus 3. So, every 1000 bits it might have error. So, if your packet size is too big, then most of the packet will be erroneous, you will be just wasting time in retransmitting. So, if there is a wireless link in between and IP works on that, remember IP layer works on top of the DLL and physical layer. This DLL physical layer can actually subside or can hide what particular media layer that is operating underlying. So, basically IP can operate in different kind of media layers. So, basically this networking that I am constructing, it might happen that first part is wireless, second part is let us say fiber optic, third part might be or some other part might be satellite. So, all kinds of links can come, but IP will still operate on top of them because it abstracts all those layer specific details in the physical layer and data link layer. So, physical and data link layer will hide all these things, IP layer can operate on top of that. Only thing is that I need to know that if the layer is not that reliable, suppose it is basically the underlying layer is wireless media, then it is not that reliable. So, IP header length has to be restricted. So, this is something which we will be doing over here. Okay. So, because sometimes it might be restricted, so it might happen that in that particular layer I have a big IP packet coming, I might have to fragment that packet into smaller packets. This is something in between routers can also do. So, basically source gives a packet, a big chunk of packet with IP header and all those things, then the in between nodes might decide, okay, this particular packet has to be fragmented. So, he makes smaller fragments and then delivers it, so that it becomes easier for him to deliver it without error, or he does not have to do too many retransmission. So, he does that, and of course, it will be then at the end it will be again defragmented, that means these packets will be again added together to construct that original packet. So, this fragmentation and defragmentation that is being handled over here, we will talk about that little bit more details. This is the error control. So, this will tell you whether the packet and the packet header, okay. So, this is sorry, not for packet, for the header, whether the header is erroneous or not, because if the header becomes erroneous, one bit of the header becomes erroneous, then you do not know whether you are doing right thing or not. So, suppose one bit of the destination ID becomes erroneous, then you do not know whether right destination you are going. So, therefore, this header checksum actually provides you whether it is, these are the redundant bit that you add with your error detection. So, that will detect, like parity bits actually, that will detect whether there is error in the header. Because it can detect, so immediately you can see that that packet is basically not good, because the header is already erroneous. So, I cannot take any decision. So, you can discard that packet. So, this is something you will be able to do. So, header checksum does that. Protocol specifies above layer what is the protocol it is handling. So, we will talk about that later when we will be discussing about TCP. TTL, that is a time to leave, that is a field which might not be that much required. This is for packet looping, we generally avoid packet looping by this field, but we will not be discussing this part because this is not very interesting. And next we have this source ID and destination ID. So, in the next class what we will try to do, we will talk about this source ID, destination ID and the fragmentation part. So, how IP with that header does the fragmentation, that is something we will be discussing, and we will also see this addressing, what kind of addressing is being implemented for IP, at least for version 4, and then we will try to see with that addressing how the networking is being built up. Okay. So, that is something we will start talking about in the next class. Thank you.